Hey everyone, Morgan here. So we're looking at page number 6 of the Chemical Reactions lecture for AP Chemistry. We're going to be balancing some equations today. And I want to tell you straight away that there is no set specific pattern that you need to follow in doing this. You just have to get the same total number of atoms on the left side and right side. They have to have the same type and same number of each on both sides. And there's no one element you start with versus any other. Okay, just look for something that grabs your attention. In number 1 here, what grabs my attention is that there's 8 sulfurs here. There's only one of them over there, so I'm going to put a coefficient of 8. Now that means 2 times 8, or 16 sulfurs for the other side, and it's balanced. I have a choice whether I can put the 1 or not. I tend to put it there just to tell me that I've double checked and thought about it, and I know that it's balanced. In number 2, you're going to see something that's going to pop up in many equations. You've got 2 oxygens and then on the other side 3 oxygens. It doesn't have to be oxygen, whatever element it might be, but when you have 2 and 3, okay, why don't we put a 2 here and a 3 there? 3 times 2 is the same as 2 times 3. Then 2 times 2 is 4 aluminums. I'm going to put a 4 there. Now, in number 3, I've got 2 bromines there and 6 there, so I'll put a 3. Okay, 2 aluminums, so I'm going to put a 2 there. Okay, works out nicely. I'll put a 1 there. In number 4, the same thing is happening again. 2 chlorines, 3 chlorines. I put the 2 there, I put the 3 there. I've got 6 chlorines on both sides. That means I'm going to need a 2 on my aluminum. Now you can stare at number 5 all you want, but the reality is it's already balanced. All ones. In number 6, we have the same thing going on again. 3 oxygens and 2 oxygens, so I'll put a coefficient of 2 there. I'll put a coefficient of 3 there. I now have 2 KCl, so I'll put that there. All right. And actually, the same thing pops up in number 7. 2 oxygens and 3, so I'm going to put a 2 there. I'm going to put a 3 there. That means I'm going to need to put a 2 on the K2S. Matches that. 2 Ks times 2, 2 Ks times 2, 1 sulfur times 2, 1 sulfur times 2. It's all balancing out. At number 8, this one can be a little challenging. I've got 2 oxygens and 1 oxygen. I'm just going to think I need to keep them even because I've got 2 over on that side. So now 2 plus 2 is 4, so I'm going to put a 2 there, and that balances the nitrogens also. Here, actually number 9 is already balanced. 1, 1, and 1. In number 10, 8 sulfurs catches my attention, so I need to put an 8 there. 2 times 8 is 16. I've already got a 2. I'm going to put an 8 there. All right. Move that up. Okay. Now, in number 11, what caught my attention was these fluorines. There's 2 and only 1 on the other side, so I'll put the 2 there. Okay. 1 sulfate, 1 sulfate. You can count polyatomic ions as a unit. 1 calcium, 1 calcium. 2 hydrogens, 2 hydrogens. That's working. Everything else gets a 1, and we're in pretty good shape. 2 fluorines and 1 fluorine for number 12. So I'm going to put a 2 there, which means I need a 2 there to cover the hydrogens. Now it actually looks like I'm balanced. 4 chlorines. Here I've got 2 plus 2. Don't forget math. 2 plus 2 makes 4. 2 fluorines, 2 hydrogens. That's good. Here I see 2 chlorines, so I'm going to put a 2 there, which gives me 2 sodium, so I put a 2 there. 2 hydroxides, 2 hydroxides. Hey, 1 cadmium, 1 cadmium. Looks good. Got some combustion ones here to look at. So 3 carbons and 4 waters. 2 times 3 is 6. Plus 4 more is 10. I'm going to put a 5 there. CH4, 1 CO2, 4 hydrogens, 2 H2Os. So 2 oxygens plus 2 oxygens is 4, so I put a 2 there and I put a 1. Okay. There you go. That's page number 6.